on 17, the last question, I was having a little bit of trouble setting up the equations.
Okay, if the optical fiber is made with, all right, other than crown glass, what? Okay. So yeah, this is a picture. So let me show this image in a new tab. Yeah, this is one where you need a bit of geometry. So so let me sketch a version here. And you will find that for the material we are covering last week and this week, and maybe first half of next week, geometry is the most challenging part. And situations like this, what I would want you to think about is, think in terms of the critical angle, which means finding that special case where something special just barely begins to happen. So this is question 17 on your homework. And first two parts are actually supposed to be easy, I guess. It's like, 90 degrees and whatever. So for the tough question, the last part, so instead of being given the index of refraction, you are trying to find what the index of refraction is. And the condition that you are given is that any light that's incident will totally internally reflect, right? Okay, so you have some different choices of incident light. You could have light that's normally incident, and I guess you could get as far away as, well, barely grazing incidence, right? Which of these two do you imagine having problem totally internally reflecting? One that's close to normal incidence or one that's close to grazing incidence? How many say grazing incidence? Right, grazing incidence? Yeah, with the grazing incidence, if this was the same index of refraction as the other one, then it'll go through and it'll be close to normal, so it won't totally internally reflect. Whereas if it's close to normal here, then here it'll be grazing incidence, so it'll be easier to totally internally reflect. So I narrow the cases I analyze that way. So I decide we are going to look at grazing incidence, or essentially where the angle of incidence is more or less 90 degrees. I mean, it's not exactly 90 degrees, then it won't be incident at all, but it's practically 90 degrees, okay? So because the index of refraction is different, this is in air, and air is 1. So after going through here, it'll refract at some angle that I need to figure out. So this will be, let me call that theta 2. And what picture do you want on this side? If you want to say that this ray of light will totally internally reflect. Yeah, you want it to barely be refracting out at 90 degrees. So you want this theta out to be 90 degrees. So once you draw this picture, then hopefully this looks like a complete picture that specifies all the parameters completely. Then the rest is a matter of geometry. And so in terms of where to start, so Javier said you are having difficulty setting up the equation, right?
Well, I got two equations, but they're just going in circles.
Yeah, that's what people mean, difficulty setting up equation. So let me just start out with what I can start out with. I see this refraction here, so I can write down an equation based on this, right? I can say Snell's law. So index of refraction and angle outside. So 1 times sine of 90 degree outside is equal to index of refraction times the theta 2 inside. So n times the sine of theta 2. All right, I have one equation, two unknowns, so I can't solve for it. So I need some condition on theta 2. And I feel like I can get that condition by, I have a refraction going on here. So I feel like I can use that to bring in more relationships that will allow me to solve for both unknowns. So the refraction, this is a new angle, so I better give it a new label, theta 3. So based on this picture of refraction there, what I would say is same index of refraction n times sine of theta 3 is equal to, well, it's going to be 1, so I'll just write down 1. All right, I have 2 equations, but I introduced one more unknown, which means I still have 3 unknown. I have one more unknown more than equations. So I needed to bring in one more piece of information. Where can I bring it?
Theta 2 plus theta 3.
They are equal to 90 degrees? Yeah, how do you know that?
First, like the size of the media is perpendicular.
Okay, you think this is perpendicular, okay?
Yeah, and so that means the perpendicular of the first.
Okay.
The normal of the first fraction is parallel to the opposite.
Okay. Oh, I see. You're going. Yeah. So with it, yeah, I see where you're going. So you're trying to move these angles there, right?
Yeah.
Let me do it the other way. So with the geometry, so you haven't. A lot of people haven't had much practice in geometry before this class. So you're just gonna have to get the practice as you're doing homework. What I like to do is I like to draw auxiliary figures, figures that are not there initially, but the figures that you can draw new based on the information you have. So these perpendiculars that I've drawn are an example of those. And once you draw enough of those auxiliary figures, what you will see is you will begin to see other figures. That's going to help you make some determinations. So the way function was suggesting is one way. So with the geometry, there's more than one way to get to the right answer. This is one of those ways where I see, oh, this is a right triangle. So these two are the two other angles of right triangle. So they must add up to 90 degrees. So if you're doing it correctly, whichever way you go, you end up with the same answer. The theta 2 plus theta 3 is equal to 90 degrees. So this now ought to be solvable. I have 3 equations and 3 unknowns. So I ought to be able to solve for n, eliminating theta 2 and theta 3. Good? Do you feel like you can take it from here, Javier?
That's where I got stuck.
All right, so let's just work through this. So I do like to divide all physics problem solving into 2 basic steps. The first step is coming up with a system of equations that relate to all your knowns and unknowns. This is the part that I like to think of as being physics, because you have to be able to analyze your physical situation, come up with this. Once you got to this part, then the second step is it's just mathematics. And that's the part that a lot of people find intimidating because, frankly, you don't get enough practice solving system of equations in your math classes, when in fact that's the most important thing in physical problem solving. So if you are able to get to this part, I would at least give yourself a pat on the back for solving the physics portion, and the rest is the math portion that I will work through. It sort of comes with the practice. This is the part where I wish all of you had a really good math teacher and learned how to do this, but I know most people didn't. So my goal here is to solve for n. I don't really care for these angles here. So I want to be deliberate. So what I'm going to do is each of the steps I take, they are designed to eliminate each of these other 2 unknowns from my system of equations. So one of the things that this means is that I will not solve anything for n until the very end. Because so whenever I solve for something, it's because I'm trying to eliminate it. For example, I'm going to solve this for theta 3. So when I do that, so theta 3 is equal to 90 degrees minus theta 2. The reason I did this was so that I could eliminate theta 3 from this equation. So I plug this in here. So this becomes n times sine of 90 degrees minus theta 2. Who's good with trigonometry here? Can I simplify this as something else? Cosine of theta 2. So it's n times cosine of theta 2 is equal to 1. All right. I have 2 unknowns, n and theta 2. And I have 2 equations, so I feel like I ought to be able to solve it. Am I going to have to eliminate n?
That's where I got stuck because I set them equal to each other and then.
Yeah, it's okay. I will tell you two different ways. If you don't want to take any shortcut, then this is what you would do. So you treat this as one unknown, x. And my goal is to first rewrite this in terms of this x instead of theta 2. Well, I know cosine of theta 2 is equal to square root of 1 minus sine squared theta 2. Everyone knows that? Yes? Or in terms of this x, it'll be square root of 1 minus x squared. Yeah. You can plug this in here. So I guess solve this one for x, plug it in here, and then solve the whole thing for n. That's one way to do it, sort of straightforward, no shortcut, substitution only kind of way. It takes way too long. Let me show you a shortcut. So the thing about shortcut is that there are no hard and fast rules. Sometimes you have to break some rules to take that shortcut. Here the rule I'm going to break is I'm actually going to eliminate n, because that's going to make things a little bit easier for me. So instead of going through this no shortcut way, let me take the shortcut. So the shortcut I'm going to take this. I have this equation, and the other equation I have from here is n sine theta 2 equal to 1. So I stare at it for a bit. I realize if I take the ratio of the two sides, two equations, then n will cancel out. As n cancels out, I end up with sine over cosine. What is that equal to? Yeah, tangent. Tangent theta 2 is equal to 1. One hint, whenever you're solving for an angle, you want to have a single trigonometric function of sine, cosine, or tangent. So this is one way to be able to solve for theta 2 really quickly. So arctangent of 1 is, everyone knows that, 45 degrees was what you're thinking of? Yes? So you know theta 2 is 45 degrees. Now you can plug it back in here to solve for n. So sine of 45 degrees 1 over root 2. So n would be equal to square root of 2 or approximately 1.4 something. Good? So yeah, that's. So if we were able to get to the setting of equations portion, that is the first important step. Now, one of the downside of this online homework system is that you can't see that you have done that part well, right? Because all you know is that either you get a numerical answer that doesn't check out or whatever. So that when you get stuck in that situation is really what that online Slack website is for. I'm there online most of the time, so you can show me what you have done so far. I can verify that, yes, this is correct. And the only thing you have left is working through the algebra and trigonometry.